All right, we are going to discover a new number today. And how we'll do that is we'll start with using our compound interest formula. So let's write that out. We have A equals P times 1 plus R over N to the NT. Just a reminder, our A is the amount that we end up with. The P is the principal, or our initial investment. Our R is our interest rate written as a decimal. N is the number of times we compound something, and T is our time measured in years. Now, let's imagine that we invest $1 at an interest rate of 100%. Okay? So, we have $1, 100%, and we're just going to say we'll invest that one time. So it compounds one time for 1 year. Okay? So, here are the things we know. We've got $1. Our rate is 100%. All right, so I know that 1 divided by 1 is 1. I know that 1 plus 1 is 2. 2 to the 1 is 2, and then 2 times 1 is still 2. So this gives me 2. Well, the only thing I'm going to change about this as I continue is how often I am compounding this. So let's go, instead of annually, let's say that we have semi-annually we are compounding it. So we have $1, we get it back, 100% interest rate, semi-annually, so then it'll be 2 times 1. And let's see, we get 1/2 plus 1 is 1.5. 1.5 squared, or 1.5 squared, we end up with 2.25. Alright, so that was semi-annually. Well, what if we change this? What if we went to quarterly? What would change? The end value would change. So we have $1. We get our investment back at 100%, compounded 4 times a year for 1 year. So we end up with $2.44. Okay? And the decimals do keep going. So as we continue, we'll look at more of the decimals here. Well, let's say that we increase this. Now, if we have $1 and we compound it monthly, what will that become? Well, if we use our calculators, we will end up with approximately equal to 2.613, and it continues, right? Now, and this is approximately also from before. Now, if we think about this, if I'm compounding this $1 at 100% more and more and more, so more often or more frequently throughout the year, I could compound it even daily, right? Now, notice my numbers here. I've got 2, I've got 225, I've got 244, 261. So each of these has jumped up by about 20 cents almost. Now, what would happen if we continue to increase this value of 12 to daily, or even more than that? Well, we're going to see what happens. I want you to think for a moment, what do you think will happen to this number, our amount, if we keep increasing it? And let's see what it actually does. So let's see what this looks like if we compound it daily. We have 1 plus 1 over 365 for convenience sake, approximately equal to, so we'll plug that in our calculator. You should be doing this with me so that you can see if you're getting the same answer. So I got approximately 2.7145667. It keeps going, right? Now, that was quite the jump, right? From 12 times a year to 365 times. Well, what if we did, and we only changed by about 0.1. What if we change this to 1,000,000? So we're compounding it 1,000,000 times in 1 year. It would look like 1 times 1 plus 1 over 1,000,000, 6 zeros, to the 1,000,000 times 1. All right, so I'm thinking, well, I know it only increased by a little bit, but it probably gets to like 2.85 or something. It's got to get higher, right? So in my calculator, I am calculating this, and I end up with approximately equal to 2.7182,805, and it keeps going. Well, now notice how we compounded this 1,000,000 times, which is way bigger than 365 times. But notice how it only changed at not the tenths, not the hundreds, but the thousands spot. The thousands spot was the first place that it changed. So notice how it's like we're approaching a specific number. So as we kept growing, as this n value kept growing, we were approaching a specific number. And right now, something that should be ringing in your head is a word that means that we're getting close to something and we're approaching it. We might not ever touch it, and that word is asymptote. So this asymptote actually, or in this case, it would actually be more considered a limit. So as our n value here goes closer and closer to infinity, we reach a very particular number. And it's really close to what we had here. And the number is E. And E, it comes from the person who came up with it, but we have the letter E in our calculator, and it's approximately equal to, so on your calculator you should be able to find this. It should be, if you press second and then the division sign, you should find it, and E is approximately 2.7182818, and it keeps going. Notice how we were very close. We had 2.71828, and then we missed it at the end here. But we got very, very close to this number, which, as we have $1, and we earn 100% of that as we compound that over and over and over again, more than 1,000,000 times, then we reach this value. And what this value is really helps us when we compound something not just monthly or semi-annually or daily or 1,000,000 times, but this helps us when we compound something continuously. In the next video, we'll show more about that. But on your calculator, you'll notice that there's an E button. It's similar to pi, where pi stands for a number. E also stands for a number. So now, whenever we talk about E, we will be talking about some number, which is approximately 2.7. Okay, so notice where that is on your calculator. It's actually in two places. One of them has an exponent, one of them does not. But now we have a new number that we will be working with.